Hi everybody. Today we're going to take a look at molecular formula, which is really somewhat similar to empirical formula. So let's start off with a quick review of empirical formula. So I gave the example before of CH. CH is my empirical formula, but remember, that's like the lowest common denominator. That would be telling me my ratio of carbons and hydrogens in the simplest form, but it is not necessarily a compound. However, if I can apply some type of multiplier to increase the number of carbons and hydrogens in my compound, but I still keep that 1-to-1 ratio, I do get real compounds. For example, I can have C2H2. I still have 1 carbon for every 1 hydrogen, right? I just have 2 of each now. The ratio is still there, and that's a real compound. Same thing with C6H6, okay? So the difference here is that as I'm adding mass, and as I'm adding elements, I'm always adding the same ratio of elements. And then once I know an empirical formula, I can calculate the molecular formula if I have a molar mass, okay? For example, my CH empirical formula has a molar mass of 13. If I go and make the molecular formula of C2H2, okay, so if I've multiplied both elements by 2, all I've done is multiplied my molar mass by 2. Same thing with C6H6. I have 6 carbons and 6 hydrogens, okay, so I've multiplied both by 6, which means my molar mass has gone up by times 6, okay? So let's take a look at the steps that we need to figure out a molecular formula, and then we'll do some practice problems. So my steps to finding a molecular formula. The first thing I need to do is look at my empirical formula that I'm given in the problem and find the molar mass for that formula. I will also have been given a molar mass for a molecular formula. So I'm going to take the molar mass that's given in my word problem, and I'm going to divide it by the molar mass that I just solved for in step 1. Finally, I'm going to multiply the subscript for each element in my empirical formula by the answer that I got when I did division in step 2. Okay, a little confusing, but let's try to apply it here. So I have a molecular formula with a molar mass of 60 grams per mole. Okay, so this is going to be my molecular formula's mass, and my empirical formula of CH4N. Okay, so the molar mass of C4HN is what I need to start. Okay, so my molar mass for that is going to be carbon plus 4 hydrogens plus my nitrogen, and for that I got 30.04 grams per 1 mole. Okay, I'm going to take my molar mass, as it said in step 2, and divide. So I'm going to have my 60.0 divided by 30.04, okay? And when I do that math, I get approximately 2. So this means that 2 is going to be multiplied by each of my subscripts over here in my empirical formula. So when I do that, I get the molecular formula of C2H8N2, okay? So that would be my answer. So the same 3 steps can be applied to any of these problems that I would give you, okay? I always have to give you a molar mass and an empirical formula. So let me clear this, and let's try another problem. Okay, so then this question, what is the molecular formula of a compound with the empirical formula of CClN and a molar mass of 184.5? So I flipped the order of things a little bit, but there's my empirical formula, there's my molar mass. For my molecular formula, okay, so I'm going to start with finding my molar mass here. Abbreviate that as mm. Okay, so this time I got 12 plus 35.45 plus 14. So I have a molar mass for CClN of 61.45 grams per mole. Okay, I'm going to come over here. I'm going to take my 184.5. I'm going to divide it by the 61.45. And when I do that, I get 3. Okay, so I'm going to have to put a 3 times multiplier on each of my subscripts over here. So that means that my molecular formula would be C3Cl3N3. Okay, so let me go back to that screen with the steps. There we go. Oh, okay. So just as a reminder, and I'm going to leave the video ending here, that these are my steps to finding a molecular formula. Okay, so remember I want to find the molar mass for the given empirical formula. I'm going to divide my molar mass by the mole that I solved for number 1. Divide the molar mass given in the problem by the molar mass I just solved for in step 1, and then multiply the subscript for each element by that multiplier that I answered for in step 2. Okay. I'll have some practice problems up in Canvas, and I will be available in a conference. I will have some set times that'll be available this time, though, because my dual credit class will have a test, so I need to devote some time to be in just their space and answer their questions. Otherwise, if I'm not available, go ahead and inbox me. I will be checking my inbox even if I'm in conference with that other class. Okay? Thanks for watching, and good luck.